So hello everyone. On the last one we have discussed about the decimation in time of the fast Fourier transform. And so today we are going to discuss about the decimation in frequency. So simply, it is a popular form of fast Fourier transform algorithm, and in this the output sequence xk, is divided into smaller and smaller sequences. Okay, that is why the name decimation in frequency. The decimation in frequency is the name. Okay. So initially the input sequence xn is divided into two sequences, as we are also done in decimation in time. So उसको पहले दो sequence x1n और x2n में पहले हम divide कर लेते हैं, consisting of first n by 2 samples of xn and the last n by 2 sample of xn respectively. Okay, so this is how we divide the whole sequence. So let's see further. So to divide n point sequence xn into two n by 2 point sequences, so the former n by 2 points, which is shown by xn, this will range from the value n should be from 0 to n by 2 minus 1. Okay, and then next the later n by 2 points should be, this should be x n plus n by 2. This should be from where the value of n should be from 0 to n less than or equals to n by 2 minus 1. Okay, so since xk is written as summation n equals to 0 to n minus 1, okay, xn, and w, this should be capital N to the power n k. Okay, and this should further divided as, इसको आगे आप इस तरह से कर सकते हैं, from n equals to 0 से n by 2 minus 1. Okay, because we have divided into n by 2 points, xn, wn, nk. Okay, plus n is equals to, so next n by 2 points, n equals to n by 2 to n minus 1. This should be xn, w capital N, n k. Okay, so this is how we are going to divide this. So further you can see this should become n equals to 0 say n by 2 minus 1 xn w capital N to the power n k plus summation of n is equals to 0 से अगर हम इसको n by 2 minus 1 लेंगे तो you need to write down as x from n plus n by 2. okay, ये यहाँ से w n n plus n by 2 k. okay, so this is similar, but we have only changed. You can see that we have the summation over here from n equals to n by 2 minus 1. This is same here, but we have the summation from n by 2 से n minus 1 तक. ठीक है, जब हमने इसको n equals to 0 से n by 2 minus 1 लिया, so we have to change the value of n over here. Okay, so we have just changed it as n plus n by 2 instead of n. Okay, so this will become, you can see this summation n is equals to 0 से n by 2 minus 1. ओके, ये दोनों समीशन अब सेम हो गए, तो अब आप इसको क्या लिख सकते हैं, एक्स एन प्लस डब्ल्यू कैपिटल एन एन बाई 2 के एक्स एन प्लस एन बाई 2. okay, this should be w capital N and k. okay, and this will become n is equals to 0 से n by 2 minus 1 xn प्लस -1 की पावर k x n प्लस n/2 w n n k. Okay, where this k is equals to 0 1 2 and -1. Okay, this should be like this. Now you need to separate the even and odd numbered samples. To separate the even and odd numbered samples. इसके even और odd number sample को हम अलग कर लेंगे. तो let k is equals to 2r and k is equals to 2r plus 1. ओके, जहाँ पर k की वैल्यू r की वैल्यू आपकी क्या होगी, r इज इक्वल्स टू 0 1 2 n/2 -1. ओके, तो यहाँ से अगर आप देखें तो x 2r आपका क्या हो जाएगा, समीशन ऑफ n इज इक्वल्स टू 0 से n/2 -1 xn प्लस xn प्लस n/2. और यहाँ पर ये हो जाएगा wn/2 nr, where r is equals to 0 1 n/2 -1. okay, and x 2r plus 1 ये क्या हो जाएगा आपका, ये सिंपली हो जाएगा n is equals to 0 से n/2 -1. okay, in bracket xn minus x of n plus n/2. okay, here w n to the power n, w n/2 and r. here r is equals to 0 1 n/2 -1. okay, so let us suppose x1 n इज इक्वल्स टू क्या है, ये हमने मान लिया xn प्लस x ऑफ n प्लस कैपिटल n/2. ओके, x2n क्या है, x2n सिंपली आपका हो गया xn माइनस xn प्लस n/2 ओवर हियर. ओके, एंड दिस इज wn टू द पावर n, जहाँ पर n की वैल्यू आपकी क्या है 0 1 अप टू n/2 -1 एज इट इज़ कमिंग. ओके, ये जो आपकी आ रही है. ठीक है, अब यहाँ पर आप सिंपली देखें तो यहाँ पर आपका कैपिटल X 2r क्या हो जाएगा आपका, समीशन ऑफ वी हैव ऑलरेडी हेयर फ्रॉम हेयर वी आर टेकिंग, यहाँ पर हमने जो वैल्यू सपोज करी है वी आर जस्ट गोइंग टू पुट इन द अबव इक्वेशंस. सो व्हाट वी विल गेट इट लाइक दिस, n इज इक्वल्स टू 0 से कैपिटल n/2 -1, ये आपका हो जाएगा x1n. ओके, w n/2 टू द पावर nr, यहाँ हो जाएगा r इज इक्वल्स टू 0 1 n/2 -1. ओके, एंड सिमिलरली x 2r प्लस 1 इज इक्वल्स टू, यहाँ से आपका हो जाएगा n इज इक्वल्स टू 0 से simply n/2 -1, and this will become x2n w n/2 to the power nr. r is equals to 0 1 2 -1. okay, so this is how we are getting these two values, means the x2r and x2r plus 1. So this is how the sequence is being divided into the odd and the even, जिसको हमने दो पार्ट्स में सिंपली डिवाइड कर दिया, means simply the decimation in frequency. Okay, so this is the even part of that and this is the odd part of that particular sequence. Okay, so this is the decimation in frequency. So simply if you are going to compare the decimation in time and decimation in frequency, then you should analyze that in decimation in time fast Fourier transform, the input is bit reversed and the output is natural order. Okay, natural order. Whereas in decimation in frequency fast Fourier transform, the input is natural order, natural order, and the output is bit reversed order. Okay, one is this. So this is all in this lecture about the decimation in frequency. So kindly try to do some numericals depending on this. Okay, thank you, thanks a lot.